Have you ever looked at something amazing generated by AI? A stunning image, maybe a piece of music, even an entire article, and just wondered, how did it really create that?
Hmm.
Is it actually original, or is it just, I don't know, brilliantly reassembling bits and pieces of everything it's ever seen?
That's the million-dollar question, isn't it?
It really is. And today, we're diving into this really fascinating area. It sits right at the intersection of cutting-edge AI
Mm.
and that age-old concept of intellectual property, copyright.
Welcome, everyone. We're doing a deep dive today into the very fabric of how generative AI actually works, and, crucially, why that technical reality has such profound implications for creators and for copyright law.
Yeah.
We're drawing our insights from a really detailed analysis. It was prepared for the European Parliament's Committee on Legal Affairs, a report from July 2025 by Dr. Axel Brando of the HPES lab down at the Barcelona Supercomputing Center.
Okay, let's try and unpack this. So imagine you're a painter, right?
Right.
And an AI just creates an image that feels eerily similar to your unique style.
Right.
How do you even begin to prove that connection? And what does it mean for your rights? That's sort of the mission we're on today.
Exactly.
You want to understand the statistical nature of this Gen AI, the big challenges it throws up for determining, novelty and attribution, and maybe what technical and policy solutions are starting to emerge.
There are some really crucial insights here.
Yeah, get ready for some moments that might just shift how you think about AI-generated content entirely. So maybe let's start with the basics. We hear all the time about AI generating text, images, music,
Uh-huh.
but how is this fundamentally different from, say, an AI that just identifies a cat in a photo? We've had AI doing that for years, right?
Yeah, it's a really crucial distinction. Traditional AI, like you said, often focuses on prediction. It basically maps an input to an output.
Okay.
So like classifying an image, saying, yep, that's a cat. These usually pose minimal copyright risk because the output, the label cat, isn't typically a protected work itself.
Right, makes sense.
But generative AI, or Gen AI, it completely inverts this logic. It doesn't predict, it synthesizes entirely new data points. It makes the cat picture rather than just identifying one that already exists.
Got it. So it's creating, not just classifying.
Hmm.
Now, here's where it gets, well, really interesting for me. The report describes a Gen AI model as a high-dimensional hypersurface. That sounds incredibly complex. Could you maybe break that down for us, help us visualize it?
Yeah, absolutely. Let's try. So imagine a vast, incredibly deformable landscape. Or maybe think of it like a huge rubber sheet stretched in many, many dimensions, way beyond our usual three.
Okay, many dimensions, right.
During training, this sheet gets shaped by, millions, maybe billions of data points, images, text, whatever. It bends and stretches to kind of approximate them all, like a blanket settling over lots of different objects underneath.
So it's learning the overall shape of the data.
Exactly. It's learning the patterns and the relationships within all that data. Then generating content means essentially picking a point on this learned surface. And the model then sort of projects that point back into something we can recognize: an image, a sentence, a sound.
So the output isn't a direct copy of any one thing it learned from. It's more like an indirect result of everything the AI has seen.
Precisely.
Like a statistical echo, maybe. Not a direct replay.
That's a great way to put it, a statistical echo. And this creates what the report calls a persistent functional dependency.
Functional dependency. That's
Okay,
fine.
between the training data, all of it, and what the model generates. The big challenge, though, is that this relationship isn't directly traceable. You can't easily point back to a specific original piece of content that caused a specific part of the output.
Right, because it's been averaged out almost.
In a very complex, high-dimensional way, yes. The aha moment here is that the AI isn't just learning facts, it's learning the relationships between data points. It generates from those learned relationships. That's what makes tracing it back to a single source so incredibly hard.
Wow. Okay, so that fundamental dependency, as you called it, it immediately brings up two massive questions for copyright, doesn't it? Novelty and attribution.
It absolutely does. There are the twin challenges here. The first one is novelty. Is a generated output genuinely new? Or is it what the report calls stochastic parroting?
Stochastic parroting.
Yeah, it sounds funny, but it means the AI is statistically reproducing patterns that are so close to stuff in the original training data, it's almost like a sophisticated copy, but it looks novel.
Okay, so not an exact replica, but maybe suspiciously similar.
Exactly. Eerily similar sometimes.
Oh.
And the second challenge is attribution. How on earth can we determine if an output is meaningfully derived from specific training examples?
Right.
Current models just offer no reliable way to quantify or trace that influence. And that, as you can imagine, is a major headache for copyright holders.
You mentioned high-dimensional spaces earlier, talking about that hypersurface. How does that make things even harder? I mean,
Yeah.
harder than they already sound.
Yeah, this is where something called the curse of dimensionality really kicks in. It's a known issue in maths and computer science.
The curse of dimensionality.
Okay.
Imagine trying to find, I don't know, a specific grain of sand on a vast beach. But in this beach, every grain looks almost identical from most angles, and just tilting your head slightly makes it look completely different.
Weird beach?
Yeah, it is. In spaces with hundreds or thousands of dimensions, our normal, everyday ideas of closeness or similarity just kind of break down.
How so?
Well, statistically, most points end up being almost the same distance apart from each other. It's counterintuitive.
Really?
Yeah. And a tiny change in just one dimension could lead to a huge perceptual difference in the output. Or, conversely, something that looks very different to us might actually be represented by points that are mathematically quite close on that hypersurface.
Wow. Okay.
So this makes it incredibly difficult to objectively assess how close a generated output really is to any specific points in its training data. So if I'm getting this right, our usual tools for measuring similarity, things like, I don't know, cosine distance or maybe perceptual hashes, they just don't really work properly in these high-dimensional AI spaces.
They struggle, yeah. That's putting it mildly.
What makes them inadequate here, exactly?
Well, they often lack the necessary robustness. They weren't really designed for determining substantial similarity or derivation in these incredibly complex, high-dimensional scenarios generated by AI.
Okay.
The report really emphasizes that novelty in Gen AI needs to be reinterpreted. It's not a yes-no thing anymore. It's more like a probabilistic property.
Probabilistic. So like the chance of it being new?
Kind of, yeah. It's about the likelihood of something being genuinely novel given the training data, which is much, much harder to prove definitively.
Okay, so we understand it's hard to define similarity in these weird, vast AI spaces. But let's get practical. What actually makes it so difficult to trace the connection? What causes this traceability gap people talk about?
Right, the traceability gap. The report points to three main technical reasons for this structural disconnect.
Okay, what are they?
First, stochastic training regimes. Stochastic just means there's randomness involved.
Right.
During training, the AI learns using random sampling of data, random initial settings. Think of it like trying to perfectly retrace every single step someone took through a winding, crowded street market during a thick fog.
You just couldn't.
Exactly. You can't easily reverse engineer the exact learning path. Second, parameter entanglement.
Entanglement. Sounds complicated.
It is. We're talking billions of tiny parameters like digital knobs inside the AI. They're all adjusted together during training in this incredibly complex optimization process.
Okay.
Imagine a giant, intricate spider web. If you pluck one tiny thread, the whole web vibrates in response. It's impossible later on to look at a vibration somewhere else and say, that specific thread caused this vibration. It's all interconnected.
So no single output traces back neatly to just one part of the training.
Pretty much no. And the third reason is simply a lack of attribution layers.
Meaning?
Well, unlike, say, citing your sources in an academic paper or a book, there's just no built-in mechanism for the AI to say, hey, the pattern for this part of the image was strongly influenced by that specific input image, or this turn of phrase likely came from this set of documents.
It just doesn't have that function.
It doesn't have that mechanism for giving credit baked in, not in most current architectures anyway.
Okay, let's try and pull this all together. We've got the hypersurface, the curse of dimensionality, stochastic parroting, the traceability gap. What are the real-world implications? For you, the listener, maybe you're a creator or rights holder, or it's someone trying to figure out what's fair here.
Well, the direct impact is pretty significant. This inability to reliably trace influence seriously undermines our right shoulder's ability to even assert if their work was used in training. let alone prove it in a legal sense.
Hmm.
It makes establishing concepts like derivative use or non-authorized adaptation under existing copyright law incredibly complicated.
Yeah, I could see that.
And naturally, it makes figuring out fair remuneration almost impossible right now. How do you pay someone if you can't tell if or how much their work contributed?
Right.
This is particularly relevant, the report notes, for legal exceptions like the text and data mining or TVM exception. That came from the EU's Digital Single Market Directive.
Okay, the TDM exception, remind us quickly what that does.
Sure, it's a specific legal provision, mainly in Europe, that allows, under certain conditions, copyrighted material like books, articles, images, to be mined, basically,
Hmm.
used to train AI models, often without needing individual permission from every single rights holder. Usually for research, but sometimes broader uses too.
Right. So AI companies can train on lots of data.
Yes, but here's the catch.
Hmm.
If models trained under this TDM exception later generate outputs that do substantially resemble copyrighted works in the training set,
Uh-huh.
but you can't establish attribution because of that traceability gap we discussed.
You can't enforce the copyright.
Well, legal enforcement becomes practically infeasible in many cases. It creates potentially a huge loophole. You might have a situation where the training was legally permitted under the exception, but the output feels like infringement, yet you can't prove the link.
Wow. Okay, that's a major issue, which brings up a really important question. Is this traceability gap just an inherent limitation of AI? Is it something we just have to accept? Or can it actually be fixed?
That's a crucial point, and the analysis in the report is quite clear on this.
What does it say?
It says this is not an intrinsic, unfixable limitation of AI technology itself.
Oh, okay.
It's framed as a contingent technical challenge, solvable in principle. Basically, it's hard, but not impossible. It requires sustained research and, importantly, institutional support.
So it can be solved. Are people working on it?
Yes, definitely. There are early-stage initiatives exploring potential solutions. The report mentions, for example, pilot efforts by GEMA.
GEMA, that's the German Music Rights Organization.
That's right, the German Society for Musical Authors and Rights Holders. They're running projects trying to develop ways to assess whether specific musical works in their repertoire might have been used during the training of certain AI music models.
Interesting. So proof of concept work is happening.
It is. And the key takeaway here is that the current lack of attribution isn't some fundamental law of AI that gives a free pass for non-remunerated use. It's a technical hurdle that needs focused effort to overcome. It's really a call to action.
Right, a call to action. So we've identified the problem, why it's a problem, and that it's potentially solvable. Now, what are the concrete recommendations? How do we move forward? And crucially, who bears the responsibility for fixing this?
The report places a strong emphasis here. It stresses that responsibility must be assumed by all stakeholders involved in the AI ecosystem.
Okay, everyone's got a role.
Yes, but it particularly highlights the role of the industrial-scale Gen AI developers, the big players.
Makes sense. They're building the systems.
Exactly. The recommendation is that they must invest significantly in developing mechanisms for auditability and transparency.
Like what kind of mechanisms?
Several things are suggested. Implementing robust systems to actually assess and document the copyrighted content present in their massive training data sets. That's step one, know what you're using.
Okay. Transparency about the data.
Then, developing internal tools for what the report calls attribution inference and influence scoring. These would be techniques to try and estimate, even if imperfectly at first, which training data likely contributed to which kinds of outputs.
Trying to bridge that traceability gap internally.
Precisely. And thirdly, providing sufficient technical documentation about their models and training processes to allow for effective third-party auditing. You need external checks and balances.
So building accountability in right from the start.
That's the idea. It's about embedding transparency and accountability into the development pipeline itself.
Okay, that covers the technical side. But what about remuneration? You said that's almost impossible now. How do we rethink paying creators when we're dealing with this fuzzy statistical use instead of direct copying? That sounds like a really fundamental shift.
It absolutely is. And the report argues that remuneration schemes need to broaden quite significantly. We have to think beyond just paying for verbatim copies.
So what could that look like?
The thinking needs to include concepts like functional dependence, acknowledging that the AI relies on the data to function at all, and distributional influence, recognizing that certain data shapes the overall statistical style or capability of the model.
Okay. How would that work in practice? money-wise?
Well, the report floats several potential mechanisms, things like pool-based royalties, perhaps indexed on dataset inclusion.
So a big pot of money,
Mm.
and if your work was in the training data, you get a share.
Kind of, yeah.
Yeah.
Or maybe contribution-weighted compensation models, which would rely on those influence estimation tools we just talked about. The better we get at estimating influence, the fairer that could become. Or even things like mandatory public registries of data sources used for training specific models, increasing transparency.
It's about recognizing the value provided by the training data,
Mhm.
even when it's not a direct copy in the output, but more like the statistical vibe of the work contributed.
Exactly. It's acknowledging that diffuse statistical contribution still has value and should, in principle, be remunerated fairly.
This all sounds like we need a whole new infrastructure almost, just to handle the tracking, the auditing, the payments.
You've hit the nail on the head. The report explicitly calls for traceability infrastructure as a major research and governance priority.
Traceability infrastructure.
Okay, and this isn't just one thing. It includes developing open source frameworks so anyone can audit training pipelines, not just the companies themselves. It means creating new tools specifically designed for measuring the likelihood of data influence in these high-dimensional spaces.
Yeah.
It also involves standardized protocols for data provenance, essentially, reliably tracking where data comes from and how it's used, and establishing independent test suites for evaluating traceability and novelty across different AI models. We need benchmarks.
That's a huge undertaking. It sounds like a massive research and engineering effort.
It is, but the argument is that it's crucial for building a trustworthy and legitimate AI ecosystem.
And finally, reading between the lines here, collaboration seems absolutely essential to making any of this actually happen.
Oh, absolutely critical. The report really emphasizes this. Establishing agreed-upon technical standards for how companies document their training data and report attribution metrics is key.
So everyone's working from the same playbook.
Ideally, yes. And this needs active cooperation. You need the right shoulders, the academic researchers who are developing these new techniques, the AI developers, and the regulators all talking to each other and working together.
A multi-stakeholder effort.
Definitely. And the report suggests that the European Union, perhaps because of its work on the AI Act and the DSM directive, is actually uniquely positioned to potentially lead the way in defining these benchmarks for transparency and responsibility in Gen AI.
Interesting. So setting a potential global standard.
That seems to be the implication, yes. It's a global challenge that ultimately needs global cooperation, but someone has to take the lead in setting expectations.
Wow. What an incredibly insightful deep dive. This has been fascinating, really unpacking the nuts and bolts. We've explored how generative AI operates on these mind-bending hypersurfaces, the complexities of stochastic parroting, and this critical need for what you call traceability infrastructure.
Yeah, and I think the core message that comes through from this analysis is really clear. Gen AI's capabilities are incredibly powerful, yes, transformative even, but ultimately, they're built on mathematical principles.
Right. It's not magic.
Exactly. It's not magic. And because it's math and statistics, it can be systematically evaluated, it can be refined, and importantly, it can be subject to sensible regulation and governance.
So wrapping this up, what does this all mean for you listening right now? As generative AI continues to evolve, creating new content at just this unprecedented scale,
Yeah.
it seems clear it's inherently entangled, as the report says, with prior human work, everything that came before.
Deeply entangled.
And this raises a really powerful question, maybe something for you to mull over after this. What does it truly mean to create? And maybe what does it mean to own a creation? In a world where new content can be, quote, stochastically generated from the statistical essence of everything that came before it.
It's a profound question.
It feels like it forces a fundamental rethinking of originality itself, doesn't it? And figuring out the answer is going to shape the future of creativity for all of us.